Hi, today we are going to see time series analysis of NDVI using Google Earth Engine. So, what is NDVI? So, NDVI is a Normalized Difference Vegetation Index. This index used to identify the healthy vegetation area and unhealthy vegetation area. So, already in our previous videos, we have seen how to calculate NDVI in Sentinel-2 images. So, in this video, what we are going to do it means using NDVIs, we are going to extract the for time series values of NDVI for one particular crop field. So the application why we need to do for time series analysis of NDVI means like the application of NDVI, it will be many application it will be there. So especially for continuous crop monitoring, whenever we are planting for one particular crop in that field or some continuously for different crops means we can easily identify the that growing pattern of that crop, the phenological characteristics of that particular crop on that field, and we can identify the stress factors, diseases and the stress and other things. Then we can use it for the NDVS time series analysis for land cover change direction and for ecosystem health monitoring and drought and water stress management. Like that, we can use it for like different applications. Now we will see how we can extract the time series NDV values in Google Earth Engine. So this program it will be the continuation of for previous videos programs. So in previous videos we already explained like how to import the Sentinel-2 datasets and how to filter out for particular dates and based on clouds and for what is mask to cloud function and what it will do like that. So in this video I will do the quick recap of these codes. So first I have created one region of interest. So this will be the my region of interest means like I only for this field I'm going to extract the NDVI values. You can consider this is my agriculture field that is for my region of interest. I have created like using that drawing tools. I have created this polygon, and then for that polygon I have named it as a for region of interest. Then another function it will be there, that function is called mask to cloud. Using this function we can mask out the that clouds. So this codes we copy pasted from that Google Earth Engine data catalog. So here it will be there for function to mask to clouds and for datasets. Till this whole code we copied and we pasted here in code editor. In extra I have added this line of codes, copy properties. Without copy properties, if added means like we can't get that time and date properties in that image collection. So for that purpose only here I have added for a system time start. So then that properties of that time and month also it will be copy pasted from that Sentinel-2 datasets, and here we will get it. Then I have created one function called variable add indices. So in that function what it will do, it means like it will calculate normalized different vegetation index. So from the band 8 and band 4, we already know the NDVI formula, near infrared minus rate divided by near infrared plus rate. So that it will calculate, and it will add as a it will add another extra band as a NDVI band into that image collection one. So then we are adding this function also here in that image collection map dot add indices. Then we already added the mask to clouds. So then here what I have did it means like only for first image of this image collection I have added into the layers. Now I will run this program, you will see like what we will getting here. So this is the topmost layer, vector layer region of interest. Here it will get a it will added the like first image of that NDVI of this image collection. Here you can see like in image collection totally 57 images it will be there from the starting of 2022 2022 years. That cloud pixel percentage I have written for 20, maybe we can write it for 50. So totally now we will get for 91 images we are getting we are got for this particular places. Now we will extract the time series values for this place. So here 920 image it will be there. So I will open for one image, first image. In that first image you can see the band of NDVI, because we here we have added the that function variable that add indices, and we are adding one NDVI to that image collection. So we added this function to here in map.add index. That's why like another band NDVI it got added in this image collection. Now we are going to extract this NDVI value for this only for this particular field, this throughout 2 years. For that purpose, like here you can see the Google Earth Engine image collection charts. Here they already given the some example codes, JavaScript codes to extract the for time series values. So here in this default code, what they did it means like they have imported the for modis images. Here variable dot e dot image collection modis images. This modis images, it is a low resolution image. It has in default it has like two bands, NDVI and EVI bands, but in our Sentinel-2 image we don't have default bands of vegetation indexes. We calculated from using formula ourselves, and we added one extra band as a NDVI. But modis image it has like in default mode it has the two images. Then forest, in this place forest it will be their region of interest. They have imported from some links. That means maybe they have imported from that own data sets like that. Then here they this is the code for to printing the print and export the print and to see the time series values of that particular location. Here you can see that in image collection they have mentioned there for image collection names. Then forest, it is a region means the forest, their region of interest area. Then mean means they want to only extract the mean average value of that particular field. Scale, it is a resolution. So for the modis image it is a low resolution image, it is 500. For our case our NDVI for Sentinel-2 is 10-meter resolution, we can mention 10 or 20 meter. Then series name EVI and NDVI. They are extracting for two values from two bands for NDVI and EVI, but in our case we are going to extract only NDVI bands. So then colors also they have mentioned it here. So these are the title and other properties. What now I am going to do it means like I will copy paste this chart codes alone, and I am going to paste it in our code editor. So no need to remember the all the codes and everything to perform these operations. Just you need to understand the code, and you need to know like what are things we need to change and we need to identify, like that is most important. So now we will change this code. So for here image collection vegetation index, for our case our image collection name is dataset. So I am mentioning here dataset. Then for our case like our bands, now we are going to do it for only for NDVI. So I am going to select dot NDVI. So in this line only we are going to extract the NDVI values, only NDVI band alone. So that is the region is our case their region of interest forest, but ours ROI, that is the name. So I am changing it to ROI. Scale I am mentioning to 20. For other bands like 20 only, so 20 or 10 also we can mention it. Then our case we are no need to that set names for EV and NDVI, only NDVI alone. Then colors also like one color is enough, we will give only one colors. Then average vegetation index value of date for forest, for field we can mention it average NDVI vegetation index. We can mention instead of vegetation index we can change into NDVI value vegetation index. No, we can change into this NDVI value name. So here everything we have mentioned. So now we will run this program. So chart generating here. Here we got the for time series value of the particular location, that NDVI values. But here you can see these are like maybe in that place there will be a cloud, it will be there, or there will be like no no images it will be there, so we didn't get the images means this place are like empty. We can get to the continuous lines also we can create. For that purpose what we need to add means then here see the dates. So a point also not that much visible, so in the each places that here date also for a month everything it will be there, only single letter only it will be there. We can change the format also, then we can get for continuous line. For that purpose we need to add some extra line of code. Here I can say point size I am adding here to 3. Then for getting continuous line, interpolate nulls true. Then title here we can give that format here we can give colors month. Now we will run this program. See, now we got the very beautiful time series values of that particular car field. You can download these values as a CSV files also. Here you will get the for date wise values it will be there. So mostly this value is for -1 to +1, so it is agriculture field, so there is a no negative values it will be there. So this for that field for 2 years time series values of NDVI. So mostly whenever that peak periods it will be there. So here in these places during that in this period and they maybe they started grown one particular crop in peak stage, that whenever the crop it will be in the vegetation period, that time you will get the for higher NDVI values. So whenever this very low value it will be, that time they harvested that crop. Then in between in between that field, if you get if it is, doesn't have good vegetation condition means like in that time we will get like very less values only we will get it. So it will be like very much useful for like in agriculture field and for other properties. So here you can see the like that two graph changes. So in this graph there will be like blank it will be there, but here we after added that two one line of code. So now we are getting for continuous line of chart. So if I download that CSV file, you can get the for date wise you will get the for NTV values. So you can use it for you can do chart for in Excel or in any other software also. So based on your convenient. Thank you. Bye.